Today we're going to get more specific with, this is lecture 3, numbers. Today's topic is numbers. So we're going to go back to the basics. And we're going to talk about different types of numbers. Fun, 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 right? Okay, so the first two sets of numbers, and I want to introduce the word set here in a minute, are, and this is the first topic, natural numbers and whole numbers. And when I refer to a set is just a collection of things, objects. For instance, let's say we're talking about the cars that I have in my garage. Ferrari, Maserati, Porsche, Lamborghini. Yeah, I have those 4 cars in my garage. To call this is a collection of objects, and we can name them in set notation. And so all we do to make them a set is put them in curly braces. And we usually give them a capital letter as a name. So we could say the set C of cars in my garage are the 4 objects: Ferrari, Maserati, Porsche, Lamborghini. Okay? This is a set. And we're not going to get too far into sets. I'm just going to say this is a set. Now, an element of a set is Ferrari. It's just an object. Each individual object in a set is an element of the set. Okay? And you'll see me do this a lot later. There's a symbol for this. If I say Ferrari is an element, that's what this means. Ferrari belongs to C, and it does, because here's the C listed out. Ferrari belongs to C. Instead of writing belongs, because it takes 7 letters, I'm going to write this, which is a whole lot easier. Okay, and it's like a E. It's like a little, yeah, it's like that. Something like there. Okay? Alright, so natural numbers are sets of numbers. And they are the numbers that come natural to you. What are the first numbers that you ever learned? Drop something. They're counting numbers. And that's what the natural numbers are. 1, 2, 3, 4. Now, there's no way that I could sit here going until the end of time and I still would not list all the natural numbers. So what we're going to use is what's called an ellipsis, which is these 3 dots, indicating that these numbers continue in the same pattern forever. So the natural numbers are 1, 2, 3, 4, 5, the numbers for counting. And they are the numbers we have used so far. And they are usually depicted with the big letter N. N is this set. And this pen is we might lose the pen before we end up here. Okay. Now the other one I talked about, whole numbers, is very close. It's a big capital W. Imagine that. And it is the natural numbers and 0. The only difference between the whole numbers and the natural numbers is that the whole numbers include 0. Because 0 doesn't come natural to you. If you drop some money on the ground, you pick it up and count it, you're not going to go 0, 1, 2, 3. You're going to go 1, 2, 3, right? Okay, so these are just the natural numbers and 0. Okay, so these numbers are special, and we're going to talk about something called closure. Something some people never get, closure. Closure. If I say an operation like multiplication, division, subtraction, that's an operation, is closed on a set, that means every number involved in the operation is in that set. For example, addition is closed on the whole numbers. Okay, so what addition is closed on the whole numbers means any two whole numbers I add, I'm going to get a whole number. 1 plus 1 is 2. Pick one out of here, add them up, and the result will be in here. Same with multiplication. Multiplication is also closed. One times 1 is 1. 12 times 1 is 1. Any number that you pick in here that you multiply by will end up in a number that's multiplied by this. That's what closure means. Okay, does that make sense? All right, well, apparently these are two of the only operations that are closed on the whole numbers. So we need some more types of numbers, because subtraction, if I say 1 minus 3, that is definitely not a whole number. So we need some more types of numbers. So the smart people sat around and thought, hey, let's invent some new numbers. And they did. They said, well, let's take the whole numbers and let's put their opposites in the same set. And this is another set of numbers. This set of numbers is called the integers. The whole numbers and their opposite. The whole numbers and their opposite. So, and the symbol for this is not I. It is after the German letter for integer Z. Don't ask me what the word is, because I don't speak a German, but I just know that integers is Z. It's a script Z. You might speak some German. Sprechen Sie Deutsch. I don't sprechen Sie Deutsch. Okay. Just know Z is the integers. Okay. So if I say -3 belongs to Z, that means -3 is an integer, and that's true. And now that we have this new set of numbers, we can say that subtraction is closed on the integers. But addition is also closed on the integers. If you add two integers, you're going to get an integer. And multiplication is closed on the integers. So we have three operations for the integers. Okay. Division is not closed on the integers, and we'll get to that in a minute. But let's discuss some meanings of these negative numbers, okay, and how we write them. Well, first of all, you can use a plus sign. To denote a positive number. But you don't have to. Okay? If you write 4, it's assumed to be positive. If you assume something to be positive when it is negative, it is incorrect. Okay? Now, how do we interpret things that are negative? Debt. Debt is negative. If you say, I have -$12 in my bank account, that means you owe the bank $12. Another big one, temperature. 30 degrees below 0 is colder than positive, so it's less than 0. Elevation. If you are 3,000 feet underwater, your elevation is -3,000 feet. Any questions over that?